In this video, we're going to be looking at a major theorem about subsequences of convergent sequences. The statement of the theorem is in front of you. You should stop the video and copy this into your notes. Hopefully you've done that. What this theorem is actually saying is that any subsequence of a convergent sequence converges to the same place that the convergent sequence converges. So how are we going to prove this kind of a theorem? Well, let's look at the scratch work. Well, I want to start by thinking about what my goal in the proof is going to be. Quite honestly, the easiest way of stating it is that I want to show that the subsequence converges to x. But now what does that actually mean? Well, that means that if I take S being any open interval that contains x, so this is an arbitrary open interval, then I need to be able to trap a capital N tail of the subsequence inside S. So then we need to show we can trap a capital N tail of the subsequence inside the open interval S. Well, let's actually draw a picture of what's going on here. Here's my number line, here's X, here's the open interval S, and I want to trap the capital N tail of the subsequence inside S. Now, in order to figure out how I'm going to do that, I really need to be thinking in terms of how the terms of the subsequence work. So let's look at the terms of the subsequence. The subsequence in this notation, what this means is that we've got P in 1, P in 2, P in 3, P in 4, P in 5, and this continues on and on forever. And I know that these P's appear in the same order that they appear in the original sequence. In other words, I know that N1 is strictly less than N2, is strictly less than N3, is strictly less than N4, is strictly less than N5, and all of these things are integers. And so what I can say is that the sequence of NKs, as k goes from 1 to infinity, is a sequence of integers that has to go off to positive infinity. And that's actually going to be kind of important. The other thing that I want to notice is that the first term of my subsequence is P in 1. The second term of my subsequence is P in 2. The third term is P in 3. The fourth term is P in 4. The kth term of my subsequence is the term P in K. And so in order to trap a capital N tail, I want all of the terms after the capital Nth term. And so I want to think about what that means. So what is a capital N tail of the subsequence look like? Well, a capital N tail of any sequence starts with the capital Nth term. Well, the capital Nth term of my subsequence is P sub little n sub capital N. And the next term will be P sub n capital N plus 1. And the next one will be P sub n capital N plus 2. P sub n capital N plus 3, and so on. And again, I want to note that I want to note that n sub capital N is less than n sub capital N plus 1 is less than n sub capital N plus 2, and so on. And this chunk here is the capital N tail of my subsequence. So now I can actually think about what it means to be trapping a capital N tail inside S. Let's go back and draw that number line again. So here's S, X, and here's S, which contains X. And to say that I want a capital N tail of my subsequence trapped in S, that means I want P sub nk in here whenever k is bigger than or equal to capital N. Now, the last thing that we need to do in our scratch work is we need to think about what the hypothesis of the theorem is saying. We now have a good idea of what it is that we're trying to actually accomplish. So now let's turn our attention to the hypothesis. And I'm going to actually put this in a different color. The hypothesis of the theorem is that our original sequence converges to X. And what does this mean? This means that we know the following. Given any open interval that contains X, there is somebody that I'm going to call capital N sub 1 inside the integers, such that if the subscript is bigger than or equal to N1, then pk is going to be inside S. Again, to just kind of draw a number line, what this is saying is that if this is X and here's my S, I know that, so I know pk lies in here when k is bigger than or equal to N1. And again, that S it contains the number X. So let me make that a little bit clearer. Now, how am I going to go from the hypothesis? How am I going to go from the hypothesis to my goal? Because remember, my goal has now boiled down to this up here. So again, how are we going to go from this hypothesis to establishing that? Well, the trick is to go back and look at one more thing. We know that these guys are marching off to positive infinity. And what that means is that eventually I'm going to have some P and K that's going to be at least as big as capital N1. And that's going to let me focus in on what my capital N is going to be. So here's how I'm going to write it down. I want to recall that N1 is less than N2 is less than N3 is less than N4 is less than, and I know that the NKs march off to positive infinity. So there has to exist a capital N inside the natural numbers such that N sub capital N is at least as big as N1 from this part of the hypothesis. This N1 is known. So I can find a little N sub capital N that is bigger than capital N sub 1. And now let's look at this. When we look at this, we can say the following. If k is bigger than or equal to capital N, then N sub k is bigger than or equal to capital N1, and P sub N k belongs to the in one tail of my original sequence, and because P in K belongs to that in one tail, so because, let me make my handwriting just a little bit better. So since P in K is part of the in one tail of the original sequence, we know P in K belongs to S. In other words, to draw one more number line, we have this situation. Here's my number line, here's X, here's that open interval S. We know that if K is bigger than or equal to capital N, then in K is bigger than or equal to capital N1, and so P in K is inside S. Oops, that should be an in K. And this is true when K is bigger than or equal to N. So the entail of the subsequence is a subset of the in one tail of the original sequence, and hence the entail of my subsequence is indeed a subset of the open interval, and that is enough to say that the subsequence will converge. And let me again get my handwriting better. So that the subsequence will converge to X as needed. And that's the end of our scratchwork version of this proof. Now we do need to clean this up into a coherent, well-written proof. We will do that in the next video.